Welcome back. Now we're going to take those systems of equations that we talked about in the last video and apply them to word problems. These are the same type of word problems that we worked in the last chapter, but in this video we're going to solve them with two variables so you can have a second approach or a second strategy to choose from. Okay, so we're going to start with the same type of mixture problem that we started with last time. That deals with interest and two different accounts with different interest rates. So let me read it to you. It says a student takes out two loans totaling $5,000 at 4% and 6% annual interest. The total interest after 1 year is $254. Find the amount of each loan. Okay, so we've talked about this before. We're going to address it a little differently this time because we're going to use two variables. But the idea that this person, this student, is getting $5,000 from two different loans, right? And so our job is to figure out how the money was broken up. How did these two amounts add to 5,000? Was one 1,000 and 4,000, or 2 and 3, or how was it, right, split up? Okay, this time, because we have the ability to solve with two variables now, we're going to use two variables. So I'll be boring and choose x and y. Okay, so we'll let x represent the loan that was borrowed at 4%, and we'll let y represent the loan. This should say borrowed, right? Borrowed at 6%. So maybe it's important to recognize that calculating the interest on something that you're investing in and calculating the interest on a loan that you're borrowing, the calculation is the same, right? Obviously, one scenario you get money and one scenario you owe money, but the way that total is calculated is the same. Okay, so if we use two variables, we need to use two equations. So you could go back to the tables we looked at in the other video. I'm not going to do that today, but you could definitely pull that in and to help you. Okay, there are two totals in this problem, right? There's the total money borrowed. I'm going to write that down. And then there's the total interest after 1 year. Okay, so each of those is going to give us an equation. So let's add up how much we've borrowed. So we've borrowed some at 4%, some at 6%. That's x and y. So if we add them up, they should add up to this total of $5,000. Okay, then we need to factor in all the percentages and calculate the interest. Let me just pencil in under here. Remember, the formula that we're using is the rate times what's called the principal. In this case, that's how much we're borrowing, equals the interest, unfortunately, that we're going to have to pay back, right? So we're using that for both of these loans. So we're going to want to use the 4%, that's our rate, times the amount we borrowed, that's the X dollars, we don't know how much it is. And that's going to calculate the interest for this one loan. So let's put that in. So if I write this as a decimal, remember 2 places to the left, that'll be 0.04 is my rate times my principal, which is x. So that calculates the interest for the first loan. I'm going to do the same thing for the second loan. So take my rate times my principal, so 0.06 y. That's interest plus interest must be equal to the total interest. We're doing just 1 year, which would be 254. Okay, so that's the hardest part for these, is setting them up, right? So we took the information that is in the problem and we used it to create two equations. Now we want to solve those equations using the strategies we discussed in the last video. So we're going to focus mostly on either substitution or elimination. And you can use either one, whatever your preference is. It's so hard to be the teacher because I have to pick one. Okay, I think today I'm going to use substitution for this one, but if you like elimination, go ahead and work it out that way. That's okay. Okay, so I'm going to label these equation number 1 and equation number 2. And I picked substitution because it would be really easy for me to solve for either x or y. And so I'm going to solve for y in equation number 1. Okay, so right now I have x plus y equals 5,000. If I subtract x over to the other side, I'm going to get y is equal to 5,000 minus x. Okay, and this should look familiar. I always like to tie these together, right? Remember in the previous video, we were solving with one variable. And so instead of using y, we used the total minus x. And that's exactly what we see when we do substitution. So these definitely sort of back each other up. It's just a matter of how you like to go about it. Okay, now we're going to use this and substitute it into the second equation. So I have 0.04x plus 0.06, and instead of putting in the y, I'm going to put in the 5,000 minus x equals 254. And this is what I was going for, right? Remember, the whole point is to be able to solve for the variables one at a time. I only have x's now, so I can go ahead and solve this just like a regular equation. I think this is going to be 300. Okay, and then I am going to combine my x's and subtract this 300 over to the other side. So I'm going to get negative 0.02x equals negative 46. And then I'm going to divide by negative 0.02. The two negatives are going to cancel, and this should give me 2,300. Okay, let's look back. Remember what x was. So that's the amount that this student borrowed at 4%. Okay, but we also want to know how much was borrowed at 6%. So to find y, we can use this 5,000 minus x, which was 2,300. So it looks like y is 2,700, and that's the amount borrowed at 6%. All right, so this is the same type of problem we've done before, but this time we used the two variable method. So on the test, you have the ability to use either method, one variable or two. And if you use the two variables, you can use either substitution or elimination. I'm trying to give you lots of options here. So you want to kind of set up a game plan. Use a couple of these to practice with and decide what is your preferred strategy, right? Kind of maybe figure that out ahead of time. Okay, here is another problem involving the perimeter of a rectangle. So we have the perimeter of a rectangle is 30 centimeters. The rectangle's length is twice as long as its width. Find the dimensions of the rectangle. Okay, so again, usually we use L for the length and W for the width. Okay, and you can do this a couple of different ways. You can, I think we showed both methods last time, okay. The first step, though, is to look for a relationship between the length and the width. And for this problem, this is listed in this second sentence. So the rectangle's length, that's L, is twice as long as the width. So 2 times W. Okay, in this particular section of the textbook, we are trying to use two variables, so we need two equations. So the other equation we need is the relationship for perimeter of a rectangle, right? That's really a formula, but the perimeter is when we add up all the sides. There are 2 lengths and 2 widths. Okay, I don't know if you could make use of elimination here or not. I'm trying to decide that, but you could definitely do substitution. So I'm going to do that. Oh, and I should have put a 30 in here. Okay, so we'll do that next. Actually, you could substitute for 2W or you could substitute for L. I'm going to substitute for L. So I'm going to put 2W in place of this L. So I'll have 2 times 2W plus 2W. And the perimeter is 30. So that means 4W plus 2W. That's 6W. And if I divide, it looks like the width is 5 centimeters. Okay, and then we need both. So go back up here. Remember the length is twice the width. So the length must be 2 times 5 would be 10 centimeters. So that would be the 2 variable approach. Right? Just because it's so easy to mention, I'm going to go ahead and put in that 1 variable approach that we did last time in case you want to see both strategies for the rectangle. Remember, you can also label your picture. Right? My length is twice my width. Here's my widths. So I could just really add all these up. Okay, of course, I'm definitely going to get the same answer. Okay. So whichever seems the easiest for you, you have these choices. Right? And now we've kind of talked a little bit more in depth about how this method would work. Okay. Here's kind of a new one. It's always good to see if you can take what you know and apply it to a new type of situation. This one says a student takes 12 credits of day classes and 6 credits of night classes. A credit for day classes costs $30 more than a credit for night classes. If the student's total tuition is $1,800, how much does each type of credit cost? I have a hunch that this might be a really old problem, but we're going to go with it. Okay, so again, we're going to practice by using two variables. So why don't we do D for day credit and N for night credit, right? And these variables, we need to look, I haven't really practiced this and I meant to, right? We look at what the question asks. How much does each cost, right? And so when we set up our variables, it needs to represent what we're being asked to find. I don't know the cost, so I need a variable for that. Okay, this middle sentence right here tells us the relationship between the cost of the day and cost of the night, right? A credit for day classes, that's D, costs more $30 more than a credit for the night classes. Okay, so we have this relationship. All right, and then we're told about this particular student who takes this many day classes, this many night classes, and pays this much money. Okay, so for each credit in the day, this is the cost, right? So our second equation should look like 12 times D, so 12 credits times the cost for each one, plus 6 times N, 6 credits times the cost for each one, must equal how much they paid in tuition, right? 1,800. All right, so this would be a good system to solve now, right? Let's try elimination and talk about what we would need to do to set this up for elimination. Okay, so let's say we're going to do elimination. Although, in all honesty, it is kind of set up for substitution. So if you would rather do that, go for it. Okay. In order to do elimination, the equations have to be organized in the same way. Right now, they're not really. This top one would need the D and the N to be on the same side. So let's just rewrite that, okay? So we're going to subtract the N over to this side. So we'll have D minus N equals 30. And then we already have 12D plus 6N equals 1,800. We'll call this 1 and 2. So if I want to eliminate a variable, how about we eliminate N? What do I need to multiply by? If I want to eliminate N, I really want the numbers in front to be equal but opposite. So I have 6N. This one's already negative, so I'd really like it to be negative 6N. So I'm going to multiply equation number 1 by 6. Okay, so that's going to give me 6D minus 6N equals 6 times 30 would be 180. I already have 12D plus 6N equals 1,800. And so to eliminate N, I'm going to add them together. This is going to give me, these are going to cancel. So I'm going to have 18D equals, what is this, 1980. Okay, so I'm going to divide by 18. So that goes in once, and 0. Hopefully I did that right. So it looks like the cost of a day credit is $110 per credit. And then, let's see, we don't have a nice place to go, so we're going to have to go all the way back to one of these two equations here. Well, actually, we could go back here also, which is pretty much the same. All right, I'll go all the way back here just because that looks like it might be easier. So D is 110, and that's equal to 30 plus the night cost. So it looks like that is 80, right? It should be less based on this problem. I wonder if it's less in real life. I never really considered that before. Okay, so we've done it, right? We've solved for the cost of each one. Okay, so I thought this might be worth it to show you that if you're going to use elimination, the equations do have to be set up in the same way so that you can add them together. This definitely would be a good problem also for substitution. So if you worked it out that way, we should have gotten the same answer. Okay, I think I have one more. And that is the chemistry problem. So we can also work out the chemistry problems with two variables as well. So let's look at what that would look like. So this one says, determine the milliliters of 10% sulfuric acid and the milliliters of 25% sulfuric acid that should be mixed to obtain 20 milliliters of 18% sulfuric acid. Okay, so there's actually two things we're trying to determine, right? How much 10% and how much 25%. So let's set that up. So we need a variable, let's just say x, okay, to represent the milliliters of 10% acid. And let's let y represent the milliliters of 25% acid. Okay, so we're going to use two variables this time. If we use two variables, we need to create two equations. I'm going to draw the chart in here just in case. I like the chart for these problems because there's so many numbers involved. So remember the relationship we use is we're going to take the strength times the amount of mixture is equal to the amount of pure, in this case it's pure acid, right? Okay, if you don't like the chart, again, some people really like the little beakers, and that's drawn out for you in the book as well, so you could do it that way. Okay, so what are we starting with? Maybe the 10%. How much do we have? We don't know. That's what we're using x for. Okay, we're going to add to that some 25% acid. How much? We're using y to represent that. Okay, and then we are given the results. And remember, if you use this chart, it's very important that the result goes in the last row so that the equation is, everything's on the correct side of the equation. We are asked to achieve strength of 18% and 20 milliliters. Okay, so this time we're going to get two equations. One of them we already have right here in the center. So the liquid amounts should add up to the 20 milliliters we're being asked to achieve. That is one equation, right? And you could also get that by just kind of adding up the amounts here at the bottom. So x plus y equals 20. Okay. The second equation is going to be based on the amount of acid involved, kind of with, if it's acid-water mixture, we're going to stop looking at the water and just look at the acid. Those should add up as well as the liquid. So if I multiply across, I'm going to go ahead and turn these into a decimal at the same time. I hope that's okay. So this would be 0.10x, 0.25y, and then 0.18 times 20. And these should add up, and this will give us the second equation. I'm going to go ahead and multiply these, right? So this would be 3.6. Okay, and the same would be true here, right? You're adding up the amounts, and then you're going to multiply, 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 and it should give you this same equation we got here. Right, these are just two visual aids, right? If you can do it without the visual aid, then no problem, right? Just two things that some people find helpful. Okay, now we want to solve this system of equations now that we've formed our equations. Again, either method works good, substitution or elimination. I'm going to do elimination one more time. This one is already set up for it. I'm just going to eliminate x. Okay, so I want the numbers in front of x to be equal but opposite. Let me label these 1 and 2. So I'm going to multiply equation number 1 by negative 0.10. Okay, so that's going to give me negative 0.10x minus 0.10y equals negative 2. Okay, and then I'm going to copy down the second equation. And then we're going to add these two equations together. The x's will be eliminated, and we'll have 0.15y is equal to 1.6. Oh, brother. I don't know if I can do this one in my head. Oh, whoops. I did. Oh, sorry. This would be like 16 divided by 1.5 or 32 divided by 3. So I'm going to get 10.666 repeating. Okay, feel free to check my math on that one. Remember what y is. Y represents the milliliters of 25% acid. So 10.6 milliliters of 25%. And then we need the value for x. This is a good place to go. So remember they're going to add up to 20. So x plus 10.6 repeating is equal to 20. So if I subtract, looks like x is going to be 9.3 repeating, right? So this is 2/3 and this is the 1/3, and this is 10% acid. Oop, milliliters. All right, so again, the chemistry problems are definitely something that you want to take some time with and practice. Hopefully you're starting to see a common thread between all of these mixture word problems so that you can kind of get a good handle on them and know what the equations are going to look like when you get them set up. Good luck with these. Study, bring in your questions, and we'll see you in the next video.